Hello, Namaste, Konnichiwa. Welcome to Sunny Sensei. Let me start this lesson with a quick question. Which of these expressions is a polynomial? Take a pause and think about it. We first need to understand what a polynomial actually is. The word polynomial has two parts. Poly means many, and nomial means terms. So a polynomial is simply an expression made up of many terms. Here is an example. 2x cube minus 7x square plus 3. This expression has three terms. 2x cube, negative 7x square, and plus 3. Now inside each of these terms, we have three important elements. First, the variable. We have the variable x in the first and the second term, and we can think of 3 as 3 times x raised to the power 0. X to the power 0 is 1. The term is 3 times 1, or simply 3. Now let us look at the second element inside each term, the power of the variable. For the first term, 2x cube, the power of x is 3. For the second term, the power of x is 2. And for the last term, the power of x is 0. And finally, we have the coefficients. The coefficient is simply the number multiplying the variable. So, for the first term, 2x cube, the coefficient is 2. For negative 7x square, the coefficient is minus 7. And for the third term, the coefficient is plus 3. So in summary, a polynomial has many terms, and each of these terms has a variable, a power, and a coefficient. Now let's look at the general form of a polynomial. Notice we have the variable x in every term, even in the last term, not visible but present as x to the power 0. Each term also has a power associated with the variable. The coefficients of the polynomial are an minus 1, and all the way down to a2, a1, and a0. Now, for an expression to be a polynomial, the power of the variable must be a whole number. It can be 0, 1, 2, 3, and so on. But no negative powers and no fractional powers. Second, the coefficients can be any real numbers. They can be positive, negative, or even fractions and decimals. As long as these two rules are satisfied, the expression is a polynomial. Now, let me go back to our example expressions and check them again one by one. We will start by writing each of these in the standard form to clearly see the coefficients and the power of x in each term. Then we will check whether these expressions satisfy the golden rules for polynomials. Rule number 1. The power of the variable must be a whole number. Rule number 2. The coefficients must be real numbers. If an expression satisfies both these rules, it is a polynomial. Let me start with the first expression. The standard form will be 3x to the power 2 plus 5x to the power 1 plus 4x to the power 0. The power of x in the first term is 2. It is 1 for the second term and 0 for the third term. The powers are whole numbers for each term. Rule 1 is satisfied. Now, for Rule 2, we will check the coefficients. We have 3, 5 and 4, all real numbers. Rule number 2 is also satisfied. The expression satisfies both the rules. So yes, it is a polynomial. Now let's move to the second expression. 1 over x can be written as x to the power minus 1. So the expression becomes 1x to the power minus 1 plus 2x to the power 0. Here, the power of x in the first term is minus 1, which is not a whole number. Rule 1 is not satisfied, and therefore this expression is not a polynomial. The coefficients are 1 and 2, both real numbers. So, Rule 2 is satisfied. But here, since Rule 1 failed, this is not a polynomial. Now let's look at the third expression. Square root of x can be written as x to the power 1/2. So the expression becomes 1x to the power 1/2 plus 1x to the power 0. The power of x in the first term is 1/2. This is not a whole number. So again, Rule 1 is not satisfied. This expression is not a polynomial. The coefficients are 1 and 1, both real numbers. So Rule 2 is satisfied. However, since Rule 1 failed, this is not a polynomial. Finally, let us look at the fourth expression. The expression is simply 5. We can write this as 5x to the power 0. The power of x is 0, which is a whole number. So, Rule 1 is satisfied. Now, the coefficient here is 5, which is a real number. So, Rule 2 is also satisfied. This expression is a polynomial. In fact, this is a special type of polynomial called a constant polynomial. The value of this expression is constant. It is always 5. So far, we have seen examples where both rules are satisfied and examples where Rule 1 fails. Let me add one more example to the list where Rule 2 fails. Square root of minus 2 x square plus 3x. We can rewrite this as square root of minus 2 x square plus 3x to the power 1. The powers of x are 2 and 1, both whole numbers. So Rule 1 is satisfied. The coefficient of x square is square root of minus 2, which is not a real number. So, Rule 2 is not satisfied, and this expression is not a polynomial. With this, let us move to another very important concept in polynomials, the degree of a polynomial. The degree of a polynomial is the highest power of the variable in the polynomial. Let me explain this using our example expressions. First, I'll remove the expressions that are not polynomials. And now, let's add a new column for the degree. The first expression is 3x squared plus 5x plus 4. To find the degree, we simply look for the highest power of the variable. Here, the powers of x are 2 in the first term, 1 in the second term, and 0 in the third term. The highest power is 2. So this is a polynomial of degree 2. Our next expression is simply 5. We can think of this as 5x to the power 0. Here, the highest power of x is 0. So, this is a polynomial of degree 0. Let me now add a few more examples to our list. The first one is 5x cubed minus 2x plus 7. We can rewrite this as 5x to the power 3 minus 2x to the power 1 plus 7x to the power 0. The powers of x are 3, 1, and 0, each a whole number. So this expression passes rule number 1. The coefficients 5, minus 2, and plus 7 are all real numbers. So it also passes rule 2. So this expression is a polynomial. The highest power of x is 3 in the first term. So this is a polynomial of degree 3. Let us take one more example. 2x to the power 4 minus x squared. We can rewrite this as 2x to the power 4 minus 1x to the power 2. The powers of x are 4 and 2, both whole numbers. So rule 1 is satisfied. The coefficients are 2 and minus 1, both real numbers. So rule 2 is also satisfied. So this expression is a polynomial. Here, the highest power of x is 4. So this is a polynomial of degree 4. Now we know what the degree of a polynomial is. But why does it matter? The degree of a polynomial helps us understand the shape of its graph. As the degree increases, the graph usually becomes more complex. We'll talk more about this later, but for now, just remember this simple rule. The degree of a polynomial is the highest power of the variable in the polynomial. The next question is, how do we classify polynomials? We can classify polynomials based on the number of terms and also based on their degree. Let us first look at the classification based on the number of terms. We will continue with our example expressions. I will remove the columns we no longer need and add 2 new columns for classifications: number of terms and type by terms. Before we move further, we first need to understand what exactly is a term. A term is simply a part of the expression separated by a plus or a minus sign. Look at our first expression. Here we have 3 terms: 3x squared plus 5x and plus 4. Remember, the sign in the front of a term belongs to that term. Notice that I said 3x square for the first term, but we could also write it as plus 3x square. So we have the polynomial with 3 terms, and a polynomial with 3 terms is called a trinomial. Now look at the next expression. This expression has only one term, 5. A polynomial with one term is called a monomial. Our next expression also has 3 terms, 5x cubed minus 2x and plus 7. And a polynomial with 3 terms is a trinomial. Moving on to the next expression. Here we have 2 terms, 2x to the power 4 and minus x square. A polynomial with 2 terms is called a binomial. So based on number of terms, we commonly use 3 names. A polynomial with 1 term, monomial. A polynomial with 2 terms, binomial. And a polynomial with 3 terms, trinomial. Now let us look at the second way to classify polynomials. Classification based on the degree of a polynomial. To start with, I will add a new column, type by degree. If we look at our examples, the polynomial 5 has a degree of 0. A polynomial with degree 0 is called a constant polynomial. As the name suggests, its value never changes. It is always 5. Now, we don't have any polynomial of degree 1 in our list of examples. So let me add one. Minus 3x minus 2. The standard form will be minus 3x to the power 1 minus 2x to the power 0. Now the highest power of x is 1. So this polynomial has a degree of 1. A polynomial with degree 1 is called a linear polynomial. This expression has 2 terms, minus 3x and minus 2. A polynomial with 2 terms is a binomial. Moving further, a polynomial with degree 2 is called a quadratic polynomial. A polynomial with degree 3 is called a cubic polynomial. As the degree increases, we simply refer to them as polynomials of degree 4, 5, 6, and so on. This example polynomial, 2x to the power 4 minus x square, has degree 4. So we call it a polynomial of degree 4. This is how we classify polynomials based on their degree. So in summary, we can classify polynomials in 2 ways. First, based on the number of terms. And second, based on their degree. And with this, we are done with this lesson. In the next lesson, we'll look at the zeros of a polynomial. If you found this lesson useful, don't forget to like, share, and subscribe to Sensei. Thank you and see you again soon in the next lesson.